You might wake up to clear skies and bright sunshine, only to see that afternoon swallowed by heavy, dark rain clouds. This condition of the atmosphere at a particular time and place is what we call weather. We respond to it instinctively, shivering when the temperature drops or sweating as the air turns humid. We feel these intense physical effects directly against our skin. Yet, looking straight up, the sky appears completely empty. To find the source of these changes, we have to leave the surface and map the invisible machinery operating kilometers above our heads. Understanding the conditions in your own backyard requires looking at the atmosphere as a stack of distinct active layers. The first layer we enter is the troposphere, extending from the ground up to 18 kilometers. This is where the planet holds its breathable air, its water vapor, and dust particles. This concentration of ingredients makes the troposphere the birthplace of all observable weather, from morning fog to these towering storms. But looking at the planet as a whole, it is clear this layer isn't distributed evenly. The troposphere's geometry changes depending on your location. At the equator, warm tropical air expands and bulges outward, making the layer thickest over the center. At the poles, freezing air contracts, creating the thinnest part. This shape-shifting engine is responsible for every weather event we experience. Punching through the turbulent top of the clouds finally brings us into a breathtaking region of total stillness. This is the stratosphere. It's stable and cloudless because earthly weather is trapped far below us. Hidden within this calm layer is a critical band of gas, the ozone layer. The ozone layer intercepts and deflects lethal ultraviolet radiation from the sun, acting as a filter for the planet. This stratospheric shield is the only reason the bustling weather engine in the troposphere supports life. Leaving the stratosphere behind, we enter the increasingly thin mesosphere. Even with its thin air, this layer provides enough friction to incinerate meteors and space debris before they can reach the ground. Higher still is the thermosphere, an extreme environment defined by direct collisions with high-energy solar winds. These solar collisions create the auroras, the shimmering ribbons of light that north the edge of our world. Finally, we reach the exosphere, the fading boundary where our atmosphere dissolves into the vacuum. This is where we place our artificial satellites, orbiting in the near-total void of the upper frontier. These outer layers serve as the planet's armor, protecting the delicate systems functioning far below. We plunge back from the edge of space, racing down through the layers we just mapped. We re-enter the chaotic, familiar weather of the surface. The weight of these stacked layers pressing down on us creates the atmospheric pressure we feel and provides the oxygen we need to breathe. The water vapor and dust we found in the troposphere, combined with the ozone shield above it, create the exact balance required for the water cycle to function. Look out your window at the weather conditions right now. The clouds or breeze you see are the direct output of a massive, invisible machine operating kilometers above your head.